வணக்கம். 9th Standard Science English Medium. Lesson number 7, Heat. Textbook exercises. Choose the correct answer. Calorie is the unit of option A, heat. Calorie is the unit of heat. SI unit of temperature is option D is the answer, Kelvin. SI unit of temperature is Kelvin. Two cylindrical rods of same length have the area of cross section in the ratio 2:1. If both the rods are made up of same material, which of them conduct heat faster? Answer option B, rod 2. In which mode of transfer of heat molecules pass on heat energy to neighboring molecules without actually moving from their positions? Here answer is option D, both B and C, that is conduction and convection. A device in which the loss of heat due to conduction, convection and radiation is minimized is answer option D, Thermos flask. Fill in the blanks. The fastest mode of heat transfer is answer radiation. The fastest mode of heat transfer is radiation. During daytime, air blows from dash to dash. Answer sea to land. Liquids and gases are generally dash conductors of heat. Liquids and gases are generally poor conductors of heat, that is convection conductors. A fixed temperature at which matter changes state from solid to liquid is called dash. Answer melting. The fixed temperature at which matter changes state from solid to liquid is called melting. Assertion and reason type questions. Make the correct choice as here 4 options are given. Option A, if both assertion and reason are true and the reason is the correct explanation of assertion. If both assertion and reason are true but reason is not the correct explanation of assertion. Option C, if assertion is true but reason is false. Then last option is D, if assertion is false but reason is true. Question number 1, assertion. Food can be cooked faster in vessels with copper bottom. Reason, copper is the best conductor of heat. Here assertion is true and reason is also true. So the answer is option A. If both assertion and reason are true and reason is the correct explanation of assertion. Here reason explains correctly. So here option A. Question number 2, assertion. Maximum sunlight reaches Earth's surface during the noon time. Reason, heat from the sun reaches Earth's surface by radiation. Here assertion is true and reason is also true. Reason is the correct explanation of assertion. So the answer is option A. If both assertion and reason are true and reason is the correct explanation of assertion. Third one, assertion. When water is heated up to 100 degrees C, there is no rise in temperature until all water gets converted into water vapor. Reason, boiling point of water is 10 degrees C. Here assertion is true but reason is false. So here answer is option C. If assertion is true but reason is false. Answer briefly. Define conduction. Process of transfer of heat in solids from a region of higher temperature to a region of lower temperature without the actual movement of molecules. Second question. Ice is kept in a double-walled container. Why? Answer. Double-walled containers are used to make ice box because the space of two walls is kept with a vacuum which provides an insulation cover to the inner box. Therefore, the outer heat of the box can't after inside the box and melt the ice. Third one, how does the water kept in an earthen pot remain cool? In earthen pot, water gets evaporated quickly through the pores. Cooling is caused by evaporation. Some heat energy is utilized during the process of evaporation. Therefore, water kept in earthen pot becomes cool in summer. Differentiate convection and radiation. Convection, flow of heat through a fluid from places of higher temperature to places of lower temperature by the movement of the fluid itself. Radiation, flow of heat from one place to another by means of electromagnetic waves. Fifth question, why do people prefer wearing white clothes during summer? During summer, most of people prefer to wear white dress because white reflects light, whereas a black object is black because it's absorbing all the light. It's not reflecting any color. So in order to keep your body temperature normal, it's better to wear white dress. What is specific heat capacity? Specific heat capacity is the amount of heat required to raise the temperature of 1 kilogram of the substance by 1 degree C or 1 Kelvin. Define thermal capacity. The amount of heat energy required to raise the temperature of a body by 1 degree C. Define specific latent heat capacity. Amount of heat energy absorbed or liberated by unit mass of a substance during change of state without causing any change in temperature. Answer in detail. Explain convection in daily life. Convection in daily life. Hot air balloons. Air molecules at the bottom of the balloon gets heated by a heat source and rise. As the warm air rises, cold air is pushed downward and it is also heated. When the hot air is trapped inside the balloon, it rises. Breezes. During daytime, the air in contact with the land becomes hot and rises. Now, the cool air over the surface of the sea replaces. It is called sea breeze. During nighttime, the air above the sea is warmer. As the warmer air over the surface of the sea rises, cooler air above the land moves towards the sea. It is called land breeze. Winds. Air flows from area of high pressure to area of low pressure. The warm air molecules over hot surface rise and create low pressure. So, cooler air with high pressure flows towards low pressure area. This causes wind flow. Chimneys. Tall chimneys are kept in kitchen and industrial furnaces. As the hot gases and smoke are lighter, they rise up in the atmosphere. Second question, what are the changes of state in water? Explain. Change of state of matter, the process of changing of a substance from one physical state to another at a definite temperature is defined as change of state. Water molecules are in liquid state at normal temperature. When water is heated to 100 degrees C, it becomes steam, which is gaseous state of matter. On reducing the temperature of the steam, it becomes water again. If we reduce the temperature further to 0 degrees C, it becomes ice, which is a solid state of water. Ice on heating becomes water again. Thus, water changes in state when there is a change in temperature. There are different such processes in the change of state in matter. Melting, freezing. The process in which a solid is converted to liquid by absorbing heat is called melting or fusion. The temperature at which a solid changes its state to liquid is called melting point. The reverse of melting is freezing. The process in which a liquid is converted to solid by releasing heat is called freezing. The temperature at which a liquid changes its state to solid is called freezing point. In the case of water, melting and boiling occur at 0 degree C. Boiling, condensation. The process in which a liquid is converted to vapor by absorbing heat is called boiling or vaporization. The temperature at which a liquid changes its state to gas is called boiling point. The process in which a vapor is converted to liquid by releasing heat is called condensation. The temperature at which a vapor changes its state to liquid is called condensation point. Boiling point as well as a condensation point of water is 100 degrees C. Sublimation. Some solids like dry ice, iodine, frozen carbon dioxide and naphthalene balls change directly from solid state to gaseous state without becoming liquid. The process in which a solid is converted into gaseous state is called sublimation. Third question, how can you experimentally prove that water is a bad conductor of heat? How it is possible to heat water easily while cooking? Answer. Take hot glass test tube and drop it in a tiny cube of ice wrapped in a gauze. Fill 3 by 4 of the tube with ice cold water and then set up the apparatus as shown in a diagram. Heat the test tube near its mouth. It is observed that in few moments water starts boiling near the top, but the ice at the bottom does not melt. This experiment shows that water is a bad conductor of heat. The crucial knowledge to understand and apply is that boiling water doesn't get any hotter than 100 degrees C or 212 degree Fahrenheit. Because of this, high heat won't cook already boiling hot food faster. Choose a pot with a lid. A boiled lid will trap faster. A large pot will take longer to boil. Numerical problem. What is the heat in joules required to raise the temperature of 25 grams of water from 0 degrees C to 100 degrees C? What is the heat in calories? Here specific heat of water is equal to 4.18 joule per gram degree C. Solution. Use the formula. The formula is Q is equal to mc delta T, where Q is the heat energy, m is the mass, C is the specific heat, and delta T is the change in temperature. Q is equal to, here m is equal to 25 gram. Then C is equal to specific heat is 4.18 joule per gram degree C. Then change in temperature 100 minus 0. If we simplify, we get 10,450 joule. Q is equal to 10,450 joule. Then second problem. What could be the final temperature of a mixture of 100 gram of water at 90 degrees C and 600 gram of water at 20 degrees C? For temperatures between the freezing and boiling point of water, the heating curve is linear. Thus, we can use 100 into 90 plus 600 into 20 by 700, or 100 into 90 temperature of first sample weighed by mass plus 600 into 20 temperature of second sample weighed by mass by 700, that is total mass. 600 plus 100 total mass. We get to find the final temperature. 100 can be factored out to get 1 into 90 plus 6 into 20 by 7. 90 plus 120 by 7 is equal to 210 by 7 is equal to 30 degrees C. The third problem. How much heat energy is required to change 2 kg of ice at 0 degrees C into water at 20 degrees C? Here specific latent heat of fusion of water is equal to 334,000 joule per kilogram. Specific heat capacity of water is 4,200 joule kilogram minus 1 Kelvin minus 1. Here heat is equal to mHfg plus m into Cp delta T. Heat is equal to mHfg plus m Cp into delta T. Here m is the mass of ice is equal to given 2 kilogram Hfg, that is latent heat of fusion of ice. Hfg is equal to, here we have given 334,000 joule per kilogram, and Cp of water, specific heat of water, is 4,200. Here change in temperature, that is delta T, is equal to 20 degrees C. Therefore heat required is equal to 2 into the 334,000 plus 2 into 4,200 into 20 minus 0. Heat required is equal to, if we simplify, we get 8,36,000 joule. Therefore, to melt 2 kilogram of ice, 8,36,000 joule of heat is required. Thank you.